Okay, so in this lesson, we're going to use the trig ratios that we looked at in the last lesson to help us find missing side lengths of right triangles. So let's take a look at our example here. And what we're going to first notice is that we have some sides filled in. We're looking for the length of x. So we have one side length filled in, and we're looking for x, and we know one angle. So when you only have one angle filled in, that's the one you'll use. Now, sometimes all three angles might be filled in which case you can pick whichever angle you want to use. But when there's only one, that's the one we'll use, and you never want to use your right angle as the reference angle. So that means that we're going to use angle A as our reference angle. So we're going to label what we know in this figure. So we know the hypotenuse is the one opposite of the 90. Now, in that one, we don't know the length and we don't need to know the length. So I probably will not use any of the ratios that involve hypotenuse. On the other hand, I want x, which in reference to angle A is opposite, and I know adjacent in reference to angle A, I know the adjacent, that's 20. So looking at our sines, so cosine, ca, and TOA, tan, we can see that the one that involves the O and the A, which is the piece that I want and the piece that I know, that would be tangent. So that's the ratio we're going to use. So here's how we'll set that up. And by the way, you are going to need your calculator, so pause the video if you don't have it. So I'm going to write the tangent of angle 30 degrees, angle A, is equal to opposite, which we said is x, divided by adjacent, which we said is 20. So I have a proportion here. I can put that over 1, and we know how to solve proportions. We've been doing that. So I'm going to cross multiply. 1 times x is x, and then 20 times tangent of 30. I don't know that off the top of my head. So I'm going to need my calculator, and you're literally just going to type the tangent of 30 degrees times 20, and you have to make sure that your calculator is in degrees, and once you do that, I'm getting approximately 11.55, and remember we're talking about a length here, so that's just units. That is the approximate length of line segment BC. So that's how we use tangent to find a missing side length. So let's look at a couple more examples. So the next one, I'm first going to just look at what I have. So again, I only see one angle marked. That's my reference angle. I'm looking at the other two sides, the one I know and the one I want. X is the hypotenuse, it's across from the 90, and 28 is the adjacent to our reference angle. Okay, so the ratio that involves A and H is cosine, ca. So cosine of 44 degrees is equal to adjacent, which is 28, divided by hypotenuse, which is x. So once again, we will set up a proportion and cross multiply. So I have x times the cosine of 44 degrees is equal to 1 times 28, which is 28. Now this one's a little different because the x is in a different place than it was in the last problem. So I need to solve for x. So just think about this. Cosine of 44 degrees, that's just some number. So that's almost like if I'm saying 2 times x. Well, how do I solve for x when I have 2 times x? I divide both sides by 2. So again, cosine of 44 degrees is just a number. So I'm going to divide both sides by that number. So cosine of 44 degrees is what I'm dividing by on both sides. So now I have x by itself. And in my calculator, I'm going to type 28 divided by the cosine of 44. So the cosine of 44 is, and I'm just going to do it this way because it might be easier. I have 28 in the numerator divided by, I'm going to keep that decimal in my calculator. I'm getting 0.719339, so forth. So I'm going to divide 28 by that. And I'm getting 38.92 approximately. And those are units. We're talking about length here. Okay. Let's try the next one. So we'll first decide what we're dealing with here. This is my reference angle. So I'm seeing opposite from that, and I'm seeing hypotenuse. The ratio involving opposite and hypotenuse is sine. So sine of 32 is equal to opposite, which is y, divided by hypotenuse, which is 15. So I'll put that over 1 and cross multiply. 15 times the sine of 32 degrees is going to be equal to 1 times y, which is y. So that's a nice easy one. I can just type in my calculator 15 times the sine of 32. And when I do that, I'm getting approximately 7.95 units. Last example. So we're looking at our reference angle. We're seeing that we have 47, which is opposite from that, and we have x, or we want x, which is adjacent. So the ratio involving opposite and adjacent is tangent, TOA. So tan of 32 degrees is equal to opposite, which is 47, divided by adjacent, which is x. So we'll cross multiply. X times the tangent of 32 is equal to 47. And we'll solve for x by dividing by the tangent of 32 degrees. So I'm running out of space here, but we'll fix that. So that gives me x all by itself. And in my calculator, I'm typing in 47 divided by the tangent of 32. So 47 divided by the tangent of 32 gives me approximately 75.22 units. Now that number seems really big, but if you go back to the problem, look at the picture, we had a really large side length to begin with. So that does seem reasonable that we would have such a large number for the length of x. And that's how we use trig ratios to help us find missing side lengths.